Hi, everyone. This is Lourdes Turecha, founder of the Rise of Privacy Tech. This is the Rise of Privacy Tech webcast, or TROPT, as we like to abbreviate here. Today, I'm really excited because we have Ethyca CEO come to join us to talk about building open source developer privacy tech tools. And it's one of the trends that we have looked at and we cover in the recently published white paper on defining the privacy tech landscape. I'm really excited that he can talk to us more about the cool things they've been doing at Ethyca in terms of building tools for developers and shifting privacy left, as we like to say. Welcome to the webcast, Kieran and Cillian, and thank you for joining us today.
Of course. Thank you for having me, Lourdes, and thank you for arranging this. I'm really looking forward to it.
Of course. Today we're going to talk about, we'll have some introductory questions about Ethyca's hypothesis. We'll talk about the series that they published on Medium. You guys should check it out about the privacy taxonomy and ontology that underlies their hypothesis. And obviously we'll talk about the recently launched suite of tools that they've built called Fiss, and we'll dig into that more later. But we do want you to know that if you have questions, you are free to share them in the comments. We will pick some of them along the way and maybe even feature them on the screen. And with that in mind, Cillian, let's start this off. I would love to learn, because I know we've only had maybe like 2 or 3 calls in the past year, but I'd love to learn about your privacy or privacy tech origin story. It takes a lot of energy to dedicate your life to something for years, and in this case building Ethyca. So I'm curious, what moved you, what compelled you to do that, and why the space, why build Ethyca?
Yeah, of course. It's a great question, Lourdes. It's a genuinely personal thing, right? I've been in software my entire career. I dropped out of a physics and CS degree in my last year, and I've worked in the industry ever since. Mostly as an entrepreneur, founding companies that are predominantly in sort of data adjacent, sort of data marketing, analytics, and sort of performance-based technology. And my first exposure to privacy regulations was a large packaged goods company, one of our customers in one of my businesses, that was attempting to prepare for the GDPR. Now, this is 5 years before it came into effect. And as a team of engineers, we knew nothing about the GDPR for sure. And assumed that privacy was some sort of subset of security as a practice, right? Like, you make the common mistakes and understands what it might be. And then you're sort of exposed to this entire world of how to address these issues. And much of what we saw was compliance band-aids. And I don't mean that to be glib. I simply mean it was sort of lots of human effort to evaluate risk and mitigate risk. But a lot of that was legal, GRC, and policy specialists, experts in their field, often not able to sort of dig deeply enough into the technology systems to make a sort of meaningful change to how that technology was treating data. And so for me, that continued to be a sort of question I constantly had, which was, we now have these complex privacy regulations. Everyone says privacy is this human right that matters, yet we still have some pretty poorly behaving technology. And I don't just mean the people, I mean the systems themselves. And so how do you fix that? And so fast forward to where we are today. So I founded, I think it's about 3 years ago. And essentially the thinking was that this is a problem best solved when policy specialists, privacy policy specialists, work very closely with engineers. And the difficulty is that engineers often don't understand either the objectives from a privacy perspective or actually just the underlying policies that are at play. And there are missing tools in the form of both education and actual physical tools that developers can apply to their systems to essentially interpret complex policy. So that was the starting point. And now, if I add a small personal point on it, is that I've got 2 young kids, and I'm very nervous about the amount of data. I just watch them using mobile devices mostly, and I'm very nervous about the amount of data that's accumulated in those systems. I think we underestimate the risk in the next sort of 2 decades of how that information is used. So if we can build technology that actually is good for humanity, I could feel pretty good about that.
Oh, you touch on so many points that we could just go off of. I mean, the first one is that privacy is so cross-functional, and you alluded to how for the first maybe 5 years of the emerging privacy tech industry, a lot of the tools have really focused on policymakers and lawyers, and that makes a lot of sense, right? Because they were the ones handling the program and building compliance. But it's really time to shift left, as we would like to say, and look at the root causes of a lot of these privacy problems, and the mounting technical debt that we've had to deal with from decades worth of, like you said, tools that weren't built with privacy or designed and engineered with privacy in mind. So one of the ideas I think you probably Nishant, we talked about that last week in our webcast, is trying to build solutions for these privacy problems as early on as possible, not just during the data life cycle when data has been collected, but during the development cycle when we're building products and systems. So why solve for this specific problem? Well, why not some other type of privacy problem? Why the development life cycle?
You kind of hit on it yourself, as you said that, which is, I think of, when I think of most of the things that are referred to in our industry collectively as problems in privacy, and this is an oversimplification for which I might get in trouble, but many of those things I think are mischaracterized as problems, and they're in fact symptoms of the upstream problem. So if you I'll just take two examples, right? Almost every company and every GRC team is concerned about enforcing some policy on data. And then they look at that and they go, well, we can't enforce the policy because we do not know what kind of data we have. So now we've got a data classification issue. And then the question is, well, we don't know where that data is. So then we have a sort of data discovery issue. And so businesses end up in this very labor-intensive human-in-the-loop process of looking for data in multiple databases, data infrastructure across the organization, then trying to agree on what types of data they are and what they were collected for and the sort of context around the information so that they can enforce a decision. So the starting point was this very simple seed, which is we'd like to enforce healthy sort of policies on our data. But in order to get there, we don't know what kind of data we have. We don't know why we have it or what we use it for or where it exists. And so you end up in this huge sort of Sisyphus-like task, rolling a rock up a hill. And so the developer tools approach or thesis that we have is all of those are a symptom of the technology that collected that information in the first place. So if I paint an alternate reality, if we could imagine the technology had been built a different way 20 years ago, if a system, the first time it collected a piece of information, in whatever way it did collect it, whether it's inferred or provided by a user, if it was able to label that and clearly distinguish what kind of information it was and the purpose for which it was collected. So a thing that we currently do manually, we sort of ascribe those properties to a system. If that existed as metadata on every piece of data flowing into a system, making a decision or enforcing a decision around policy on that would be essentially effortless. Like we'd say, okay, well, we don't want to use email addresses for this. We don't use behavioral data in these ways, but we can't because of all of the underlying technical debt, as you referred to it. And so you can only ever solve that problem if you go upstream and solve the root cause, which is the technology is not fit for the purpose that we want it to be, which is the way it collects that information, the way it labels it so that you can then enforce decisions on it. So you got to start with the software.
That, resonates a lot with me. And I'm curious, though, if we could bring it home to some of the listeners, aside from addressing the root cause, like you mentioned earlier, as opposed to the symptoms and building Band-Aid solutions for the symptoms that don't really address the root cause, right? Which is how we build technologies. What are specific use cases, just from, I know you've worked with hundreds of engineers in building the suite. What are some of the specific use cases where they've said, this is really helpful. These are the benefits of solving the problem early on. I'm curious if you give us maybe like a couple that come to mind that solve these developers' problems.
Absolutely. So I can think of a large engineering team where they, without getting into too much of the sort of proprietary detail, they have a task force of data engineers whose job it is to essentially review data infrastructure. So they follow a mandate from the GRC team. They look at data infrastructure that's sort of distributed around the world, and they essentially they label this data as sort of orphan data, right? They don't really know where it came from or how it sort of came to be in the organization. And it isn't a lack of care. It's not malpractice. It's again, as we talked about, it's sort of an anachronistic issue, right? The system was built before the regulations existed. So data was collected and flowed into a database. Maybe an engineer left the team. Maybe there was some okay documentation, but not brilliant documentation. So now nobody knows what that database does or why it's there, or what information is in it. But someone would like to maybe use it in an ML model. So first thing you got to do is figure out what information's in there and where it came from and what it's used for. That's an entirely manual process. Some businesses try to use some machine learning classifiers to accelerate that, and it does speed it up, but it's still going to be reviewed by a human being, because you get into this question of, well, was the labeling correct? And is this as an organization what we consider to be categories of personal data, identifiable, non-identifiable, the degree of identifiability? And so in that example, what I'm referring to is, for the engineer, they've been asked to basically get away from building software, which is what software developers want to do, like build awesome technology. And they've been asked to run around and be essentially forensic data accountants, right? That's all they're spending their lives doing. And when you show them a developer first approach to this, their first reaction is, well, that doesn't solve my data discovery issue. It doesn't help me know where the data is today. But then you ask them the question, well, how did that data get there? When you did your last analysis over 3 months of that database, what did you discover? And they discovered that there was a series of microservices that were deployed over 5 years, owned by different product and engineering teams, and that those services all did different things, built by different teams, documented separately, and that data flowed into different data infrastructure. And they had to effectively walk the sort of chain of service calls to figure all of that out and then document that. And then you pose the question, well, how could we avoid that in the future? Well, it's pretty self-evident then. It's, well, if it was easy, so very low friction and just part of the software development process and the tools that you use to be able to describe the service in such a way that you know what data is in it and what it's doing, that problem would never exist. All of that work would go away, and a developer could go back to building great technology really quickly and not worry about those problems. And the second part of that is the understanding for developers, right? Like, I know we'll talk about taxonomies probably a little bit later, but the developers often don't understand the law, not because they don't care to, but it's not their job, right? And so translating policy into something a developer can actually apply to a system is very difficult. And then you get into an issue of standards. Like we already, as a privacy industry, like the specialists, struggle to standardize terminology that we want to use to describe across jurisdictions. So then how do we get a developer to do the same thing? So if we don't provide them with like very low friction tools, it's very difficult to solve these problems. We're going to be unpicking data for decades.
I'm glad you mentioned the taxonomy, because this is probably the perfect time to unpack, Ethyca's privacy taxonomy, which you published in conjunction with the release of Fiss. So what is Ethyca? There are all sorts of privacy taxonomies out there. Some of them are more broad than others and more philosophical than others. This is not. Well, maybe it's a mixture of that. It's both technical and philosophical. But I'd love to ask, what is Ethyca's privacy taxonomy, and why start with one? Why did you feel compelled to release that in conjunction with a product?
Yeah. So you're absolutely right. There are many others, and we don't in any fashion want to have a monopoly on defining data for businesses. What we found over the last 3 years, and it is important to say for context for those that are watching, we started building these tools 3 years ago, right? We've released them in the last month, but it's been 3 years of hard work of designing and considering this with large technical engineering teams. And what we found was a common thread for everybody was classifying data. So simply agreeing on what kind of data exists in a database. And we say by everybody, I mean, a single team of engineers working in one company, debating the definition of data with their lawyers or legal teams. And that then exacerbates itself or compounds itself if you go across organizations, so between teams. And if data is going to flow between companies safely, then you need some standard understanding of what types of information are moving between them. But every company has its own taxonomy. Often it's badly made because it was done in a rush, not by someone who's a sort of ontological expert. So it's just a bunch of labels for information. And so what we started with the taxonomy that underpins Fiss was this a simple goal, which is we don't want to be the only authority, but we think we can take a stab at making a standard that anybody can extend. So any developer team can grab the Fiss taxonomy and essentially use it as a framework for describing the information in their systems, and then extend it so that if there are specific nuances to the types of data they manage, they can better describe that for themselves. But by arriving at a single standard, you have consistency between teams' understanding of the type of data they have. and the ability to enforce a policy on it, and also then interoperability between external systems, right, or a sub-processor or a vendor, like knowing that the data is going there and that they understand what type of data it is also. You mentioned, there's a bunch of others out there. There are a bunch of incredible efforts in this space, sort of academic, theoretical, and technical, right? Like Solov's work, which is more about risk evaluation. Then you've got CoBrave and Pronto, and they're all incredible. Our goal was slightly different, right? It was not to draft probably the world's most comprehensive view of policy, but rather a very a real world applicable taxonomy, so that any developer could read it in plain English. And even if they didn't know the law, they could understand, oh, this is how I describe location data. This is how I declare that I'm handling sensitive genetic information, and make that as easy, so we lower the barrier for developers to do that. So that becomes a consistent thing that you can do across any system.
And I love that, because obviously it's really helpful to look at all of these philosophical taxonomies that are comprehensive. And you mentioned Solov, obviously a big fan here. I've worked with him. He is one of my trusted advisors. And I do love his taxonomy, especially with Danielle Citron on this. But I really enjoyed looking and parsing through your taxonomy, because it brings it down a few levels closer to where we need it to be, to ones and zeros. Not quite ones and zeros, but one of the biggest criticisms about the tension in privacy, about focus that's high level and philosophical and principle space, is that they don't really specifically address specific use cases. And here, your taxonomy, it sounds to me, correct me if I'm wrong, addresses the developer. It's sort of like a developer privacy taxonomy for how they code, right? So how they name different privacy personal information when they build tools. And so thank you for contributing that. It's a really helpful piece of work. And you alluded to this earlier. It's available for everyone. It's open source. Where can folks find this if they want to contribute to that?
Yeah, of course. So the taxonomy is available as part of the Fides tools. So it's on github.com/ethica/Fides. Fides is completely open source, I want to be clear. So it's a free set of tools that anyone can both use, modify, contribute to, provide feedback on. And I see a question coming in there, or a statement rather, even from Christian. Thank you, Christian. Just to answer that, because it sort of plays into the point of the taxonomy. We're not suggesting we have a monopoly on this. What we're proposing is that you need a starting point that any developer can apply easily. There are standards for data classification across industries. The healthcare industry has 2 notable standards for interoperable exchange of data. So the premise of this already exists. We in that respect, we haven't done something brand new. The difference, I would say, is that we aren't just describing data from a risk modeling or governance and analysis perspective, but from an interchange format perspective. So something that can be applied and attached as metadata to every field of information that flows in a front-end application, back-end application, pipeline tool, or in a database, so that you can then evaluate risk or impose policy on it. And the key thing is it's extensible, right? So if you clone the Fides repo and take a look at the taxonomy or look at the documentation and the Visual Explorer, you'll see that it has a set of very concrete primitives that are pretty abstract intentionally, so that you can say, I'm dealing with contact information, or you can be very precise and fine-grained and say, I'm dealing with specifically email addresses or phone numbers. And those are very simple examples, right? But that is the point, so that one business could say, I am dealing with IBAN numbers, for example, where another might say, I'm dealing with financial data as an abstraction, and the policy can be enforced by both businesses at whatever level they need to, which is the whole point.
Thank you for addressing that. I was just about to read out his question, but we were able to present it on screen. I think the moment everyone's been waiting for. Let's unpack what Fides is. So, we talked about these are a suite of tools for developers. They're developer privacy tech tools. But in your own words, how would you, when you're talking to your customer, your intended customer persona, so the developers building, how do you describe it to them in a couple sentences?
Yeah.
Most, most important.
Yeah. So for those that have to do, in that case, let's say the developers that have to handle them, what we would say is Fides is a lightweight description language for privacy primarily. For those that are on the call that are from a policy perspective, you could think of it as a description language suitable to manage any governance concepts, right? That's the point, right? It's, can I describe the type of data I'm handling and then actively enforce decisions or policy or rules on that information? So at its core, it's a lightweight description language. Now, when we talk about that from an engineering standpoint, what we really mean there is sort of a primitive way to write descriptions or statements or declarations, if you will, about a system's resources. So the type of data, and by type here, if we're using policy language, we might mean the category of personal information. So, like names, email addresses, sensitive genetic information, passport data, etc. So one thing is the what it is, so the type. The other thing you can describe or declare is what you're using that information for. So it's data use or its purpose of processing. In order to align these with or translate them between the world of policy and the way developers think about systems, the way you can think about data uses in Fides is very concrete data processing activities. So for example, we use information as a statement, as a plain English statement, we might say, we use some of your behavior information to personalize our application. It's a pretty concrete use of your data, right? We use some of your behavior data for first-party advertising, so our own ads. Or maybe we use your data for third-party sharing for third-party advertising, which is to say we're selling your data. So there are very concrete constructs that essentially describe the use of the data and the flow of that information. The third is the subject, which I think everyone's familiar with, right? So the type of subject. I'm sorry, for those that aren't, the subject is the user, right? So like a customer of a system or a patient in a medical system. And the fourth dimension of the primitives that you can describe is the qualification or the degree of identifiability that a data set represents. So for example, a data could fully identify somebody because it could quite literally be information about one individual. It could be aggregated data sets that partly identify individuals. It could be unlinked, could be pseudonymized data. And each of those essentially reflect a risk factor, right? Like the degree to which I could identify an individual with a given data set. If you combine those things and you write Fides with those descriptions, you're essentially able to very easily, for a developer in a handful of lines of code, describe what your system is doing with what kinds of data and why. And if you have that information, imagine you have that from day one when you start to build something or modify a service, you can now impose decisions. You can say, well, we don't do these things with data, or we allow you to use information in these ways. So the language allows you to make these declarations, or manifests, as we call them. And then Fides supports that with a set of tools. So there's the language that sort of sits underneath it, and then there are a handful of tools. The first of those is what we call Fides Control. So Control is a management application. So for developers listening in, think of that as a server and a CLI tool. So the CLI runs locally on your laptop or workstation, and the server can run locally, but typically if you're running in a production environment, the server is really intended for use by multiple engineers in sort of a project environment. So essentially the server runs as part of your CI pipeline. You can load policies in the server, so you can essentially describe at a governance level things that you want to enforce, and those are then checked against declarations made by engineers in their projects in Git. So what that means essentially is you can manage or declare and then version privacy metadata in every Git project. So there's privacy descriptions or declarations in all of the work you do in your code base. And those are checked and evaluated as you commit code. So as you commit code, it's checking whether or not the declarations or intent you have with the project you're working on matches the organization's policies. So it prevents an engineer by making a mistake. Oh, we can't actually use phone numbers for an API that would expose that data to application developers, because those phone numbers were only collected for use in multi-factor authentication. We all know this one from the FTC consent decree with Facebook, right? That would never happen if you were using a Fides. That just wouldn't be possible if all the developers were using Fides. And on the runtime side, so what we've covered there is sort of the code management environment. So when you're building applications, so assume you've built applications and they're safe and they comply with all of your policies. On the runtime side, we've got a tool called Fides Ops. And Fides Ops is a operations or data orchestration tool. So what Fides Ops does is it essentially reads the declarations that developers have made So says it has sort of context of what data you've collected, what you're using it for, and then you can write policies against it that you want to execute in a runtime environment. So policy here might be, well, when we receive data subject requests, we return these parts of the structure of our taxonomy. So we return contact information and names and order history, but we don't return some internal notes or behavioral analysis, for example. It's a business decision at that point. It also allows you to structure erasures. So you can create policies to describe how you want to de-identify records, and it allows you to configure that so that you can pseudonymize and unlink a record across documents or different destinations or sources, so that you can get to the degree of de-identification that is applicable for your business. So instead of having to plug in lots of SaaS tools to do a data subject request, you can automate these as effectively a data orchestration process in your production environment. So those are the core tools that ship with Fides. One side allows you to manage risk and evaluation of policy while you're building product, and the other side allows you to automate privacy rights and requests in the production environment.
So obviously, thank you for that, by the way. It answers a lot of my questions, and I do appreciate the way that you started with the description language, which, correct me if I'm wrong, is intended obviously for developers, right? So the customer persona for that language obviously are the developers coding and building. I do appreciate that you start with categories, the purpose and uses, the specific data subject or user, and then the qualification, as you say, or the level of identifiability. And as a softball, why is that important, Cillian? what is, like, how does this make organizations' lives better?
Yeah. I mean, there are so many reasons, so thanks for the softball. So the first thing is that if you don't have a standard understanding is a terrible phrase. If you don't have a shared common understanding of the types of information that you're dealing with in an organization, it's impossible to evaluate risk. And so right now, the workflow that most companies probably have is a very human intensive privacy review, right? So a legal team just define what is acceptable for an organization to do. They educate the engineering team that are responsible for building those systems and maintaining that data. Those engineers are then perhaps tasked with filling in forms to describe and explain in reasonably plain English what it is that their software is doing. And then a lawyer, understandably with expertise in policy, makes a judgment call very often on whether or not that's possible or it's acceptable under the policies or governance model of the organization. All of that's very important, but it's incredibly friction-filled, very complicated in translating understanding of policy and concepts and technical concepts back and forth, and it's very error-prone. We call it privacy as code, and I guess if you think of like Lessig's work, right, it's like code or code and law should work together. Like systems are pretty immutable. You can encode or enforce decisions in them, but it's not how we do it today. So the purpose of Fides is to allow you to say, well, I can absolutely describe what my system's characteristics and behaviors are through the lens of privacy, and now I can enforce decisions on that without having to have very complex human processes, and allow policy specialists to focus on the stuff that's high risk, and allow developers to keep shipping products very quickly, and to remove all of the work that happens typically in production in a system where the risk has already been incurred.
And you're absolutely right. The way it's been done historically has been very manual, with product privacy counsel sitting in on Scrum meetings, right? And it's just chaos because lawyers and engineers don't speak the same language, and it's highly manual. We have a shortage of privacy professionals, and so to throw more bodies towards the problem versus addressing it via a tool is a big problem that we've had. And so thank you for paying attention to that problem. So it sounds to me like Fides control is obviously, in addition to the description language, is for developers. And then Fides ops, are those something that privacy program managers or lawyers would use? Because you're talking about policies and some of the rules that govern what you then do. Who's the target customer persona for Fides ops?
Yeah, that's a good question. So if you're familiar with sort of typical privacy operations around data rights, for those that are thinking about that, today that probably looks like a privacy request flows in. Yeah. And by that, I mean, it arises maybe through a customer service channel or an email to the legal team. And then they evaluate the sort of veracity of the claim and whether the identity of the user is correct. And then they kick off a process to retrieve that data, and that might be a request to engineers or various stakeholders to get that information. It's a very labor-intensive process, and there are increasingly tools that help to automate some parts of that. But most of those tools act on third-party SaaS applications, so they plug into Salesforce, they get data out of Salesforce. But if you're a business at scale and running your own databases, data warehouses, data infrastructure, and building your own machine learning models, that's not really the way this is going to work. You're going to end up consuming your engineers' time.
Yep.
And so FIDE's ops purpose is essentially to be able to turn a policy request related to privacy rights, like we need to, we have a retention policy of 30 days, we want to delete data, to make that easy for a developer to enforce on their data infrastructure. So it has a huge benefit for the legal team because you can be assured that data is being managed appropriately, and it has a huge benefit for the engineer because it removes the sort of mechanical Turk or the Rube Goldberg machine that they have to get involved with when they need to delete data normally. So it's a huge benefit for both. Practically speaking, today's implementation is for engineers. Part of the roadmap is tools and interfaces to connect it to other existing privacy tooling that you might be using in your organization, so that you can actually send requests into it.
Right. So tools that, for instance, the program managers or the CPOs or DPOs use to define rules can then feed into FIDE's ops. It sounds like is something that's down the roadmap.
Yeah, we're currently working on them. There's already APIs built in to support some of the common GRC products, because I don't want to plug anyone's products. It's basically, its intention is that you can plug FIDE's ops into whatever you're using today to manage your privacy requests, where you're doing those manually. You can plug FIDE's ops into those, send a request to FIDE's ops, and it will automate that across your data infrastructure.
Perfect. We have like a slew of questions. If you don't mind us taking a pause from our conversation, addressing some of them, I'm going to pull up one of them from Jason. So he's saying, I'm suspecting developers don't have the context to answer a lot of the privacy questions. For instance, identifiability of data. And so am I missing something? Seems like a silo developer could incorrectly identify identifiability without that larger context. So he does bring up, we have privacy engineers, but they're not the same as developers, right? Like someone like Nishant Bajaria from Uber is not actually the one who's coding. So how does the tool address that? So is the tool also open for use for privacy engineers? So there's a way for them to help define identifiability, given they're the subject matter experts?
It's a really good point. It's a great question, Lourdes, and thank you, Jason. I think in explaining the tools in the time we have, we probably rush a little bit, and it creates more questions than answers. But what I described was a developer using these, and it sounds like it's a developer in a silo, as Jason put it. A better way to think about it is, let's say you're a team of engineers, even a small team, like 10 to 15 people working together. You're going to have product owner, architect, senior engineers, team leads, and they all have a role in describing the capabilities of a product. It's through the lens of privacy. So what I mean by that is it's sort of behaviors and attributes or characteristics. So I would agree with you, Jason, that most average developers might not be able to think of the degree of identifiability that a piece of data represents, but someone needs to make a judgment call at some level, whether that's a data engineer that has composed the schema or structure of a database, for example, or the types of data that are being collected, as to the risk that might represent. Not the privacy risk, I just mean the types of data that you're handling. And we would argue actually that's something that developers need to get more comfortable with. So what we try to do is make it as simple as possible, so that you sort of lower the bar, the entry, to do that. So today you have to declare FIDEs by hand. So you write it in YAML configuration files, essentially sidecar your projects. In future, you'll be able to write it in line in your code base. And we'll be building plugins to things like VS Code and IntelliJ that hint recommendations to make it easier for the developer. But for sure, there's some learning curve. I think a healthy corollary for this would be like Terraform, right? So not every developer understands the underlying resources that they deploy in their cloud environment, like the underlying detail of the performance characteristics of given types of EC2 instances. But you know how to write a very simple declaration to request a resource to be built at runtime. That's what we're asking an engineer to get to, is that level of understanding, so that they can describe those systems in that way. And that will take time. That's the journey we got to go on.
We have a couple of similar questions coming up that are actually very important questions. So the first one is about retrofitting current code, and so that's the first question. Would there be a substantial amount of retrofitting code? And then the second one is, privacy can't be solved without solving information governance first. And so what about existing code? So it's very similar questions.
Absolutely. And it's really important to distinguish them. There is the legacy technical debt issue of systems that have been built over 20, 30 years that predate specific regulations. Our argument, very simply, or the sort of the thing that we want to put forward and get people to understand and buy into and believe in as passionately as we do, is that if you don't at some point in time change the software development lifecycle that you have, you will essentially continue to incur the same technical debt. So you will impose Mechanical Turk solutions in your production environment to create a sort of a superficial level of governance control on an existing system, but the system will continue to be broken indefinitely. You've got to go upstream and put those tools in place so that you can end that vicious cycle that you have today. So that is a long-winded way of saying today Fides is definitely best intended for go forward compliance, or it's going to solve a problem so that you don't have it again ever. There are some tools within the suite of what Fides can do that assist in describing systems already in production. It's important to say that a lot of the use cases we focus on that are more interesting are like stemming the loss and stopping it going forward. But you can use Fides to describe existing infrastructure and data sets and impose policy on those as well.
Thank you for clarifying that, Cillian. We do have an interesting question. How might Fides be used in incident response? Obviously, I mean, with that level of control, I'm assuming it will be easier to find, be able to identify breached data or data involved in a privacy incident. But I don't want to answer on your behalf. I'm curious if incident response is one of the use cases that you guys have looked into in the future.
Yeah, thank you for that's really important qualification. We're not there yet, Paul, but thank you for the question. What I would say is it isn't a today Fides is not intended as a security or IR tool, like an incident response tool. But if you consider what it can do already out of the box right now, if you had imposed it on a piece of your infrastructure that you became aware might have been breached, and you needed to draft some kind of response either to a regulatory authority or to your customers, you would have very fine-grained understanding of precisely, because if you think of it as a immutable audit trail, like a Git history for your privacy decisions tied to every service and data set in the organization. Now you want to say, well, we think what was compromised was the registration services. So someone managed to compromise those and create fake accounts and access people's accounts. You'll be able to see what data is readable and writable from your registration services, which data sets can be affected from that, and with timestamps, which records were written between those 2 points. So you should be able to report very accurately on the number of individual subjects that were affected and the individual fields of data that may have been compromised. So you get to like really detailed stuff instead of guesstimates on X number of users, possibly over a period of time. But today we don't surface the information for that purpose, but it solves those things for sure.
Thank you for that. We have one more question. I think all of the other ones are thanking you for explaining. Explainability and privacy may require a review of your code base. Is this possible? I'm assuming under Fides.
Yeah. How best to explain that? So the way to think about it today is that you're asking a developer to describe their code in a manifest or configuration file or a YAML file, if you want to get specific, that sits in the project repository. So it is important to say that in the current general available release, you're essentially entrusting engineers with the authority and responsibility to declare honestly what the work that they're doing, and then you can enforce policies in the CI pipeline. An engineer could be a malicious actor or could just make an honest mistake. But that's the current state of the tooling. The end goal is to get to where we already are and are familiar with static code analysis tools for security, right? So this isn't a dark art that doesn't exist, right? SAST tools do this very well for security, right? We look at potential open source vulnerabilities with SAST tools all the time. Everyone does. We can apply the same technologies to privacy. It's just that we don't have a standard definition for how we describe those systems or standard way to make business decisions on it. So you've got to do that first, which is have a consistent way to describe systems. And then we can learn from that. So we can start to look at, specific methods or functions that are used by developers to perform common tasks in a given service and start to look at or infer what might be happening under the hood and either provide annotations or potentially infer some risk from it. So.
It's a really important point that you touch upon, right? A lot of these, with cybersecurity being the closest adjacent industry to privacy tech, when we were defining it, we did see a lot of the tools that are being built on the development lifecycle side mirror some of the existing their security counterparts, and some of that, like you mentioned, are the static code analysis for security. I'm curious if you're also looking at the dynamic part of it, if that's part of the future, right? Down the
yeah, absolutely, Lourdes. It's a really good point. We focused a lot on the sort of in this discussion the development phase, and therefore the sort of static component of that. The reason for that is we're quite simply, as you can all imagine, 3 years old and like running like stink to work really hard, but we're tackling the problems in the order we think they're executed. So at the very, very top of the stream, to go back to that analogy, and as we work our way down, we get into what would be sort of dynamic environment issues. Yeah. So Fides Ops is a dynamic environment tool, right? Insofar as it's in your runtime. Our roadmap is to go much further than that. We will have semantic access control tools that are built on top of Fides. That is part of where we are going. Our expectation is that we'll allow you to write in plain English or a plain language a policy you'd like to enforce on types of data across systems, and ensure that that can be consistently enforced, whether you're using a sort of existing access control system or something new. The roadmap is very full and very busy for the next 5 years, but we will get to dynamic enforcement.
Thank you for that. And speaking of the life cycle and addressing things earlier on, are you guys doing anything in the requirements stage? So specific rules that either in the form of like specific rules that rules libraries that developers could use, or in Nishant's words when I was interviewing him, some sort of repository that will then kind of incorporate a lot of the technical privacy analysis that he does manually, that you could put into a repository at some point. I'm curious if it's part of the roadmap or not.
I would it's a really great question, and as you know, Nishant is like someone we spend a lot of time with, so he gives us a lot of insight into how we should think about these problems. But I would say that it's less that it's on our roadmap. Again, because Fides is open source, one of the ambitions we have is that engineers and policy teams will contribute. And so to answer that question, the repository that Nishant is referring to, I believe that's community sourced. So that is to say that everybody can create policies on top of Fides, and it would be amazing if the industry shared those policies. Remember, there's no intellectual property, and when I say there's no intellectual property, you could argue it's IP. What I mean is there's nothing sensitive or classified about your organization. These are constructed declarations about what we might do with data. When we build machine learning models, we want to ensure that we exclude certain types of behavioral information because we believe they might compromise a user's identifiability, right? Like K-log K stuff. That's a policy that a very sophisticated team of machine learning engineers could enforce in a system, and an earlier stage company might not have the sophistication to do, but could well benefit from that policy existing or being drafted. So ideally, you end up with a public registry of policy that could be enforced by jurisdiction, and anybody can pull from it.
So based from what I learned from you today, Cillian, it sounds like the suite of tools that you described, so the description language, Fides control, Fides ops, they sit under the design, build, verification stages of the development lifecycle. But correct me if I'm wrong. And then obviously the open source stuff are under requirements. But if that's incorrect, please correct me.
No, you're right. I think the simplest way, we have a very boring diagram for this, which I think is in one of the articles about the taxonomy. And if it's not, we'll share it with you, Lourdes, and you can share it with me. But it's
obviously, and the link too.
Yeah. Happy to. And it's if you can imagine it as a sort of a left to right diagram or spectrum of the software development lifecycle. Fides, the language, crosses everything, right? So it's supposed to be a consistent part of all of your systems. Fides control sits in the code management side of it. So the left side, where you're building things and you want to make sure that you're building things that either comply with a law or comply with a policy the business has, a code of conduct or ethics. And Fides Ops sits on top of the language, but on the right side, where you've already built your application, it's now collecting people's sensitive data, and you want to enforce some business condition on that system, some rule on it. So the language is sort of across everything. Control sits on top of software development, and ops sits on top of deployed systems that are in the real world collecting people's information.
That makes sense. Thank you for clarifying that. Okay. You mentioned the roadmap a couple of times. I wonder, I know without disclosing confidential information, I wonder what are some of the neat features and products that you're building that haven't been released yet that developers out there should be looking out for? What is the future of Fiss?
Yeah, definitely happy to share, like excited to share. The goal ultimately with Fiss is to lower the bar of entry so that every developer can, in air quotes, do some kind of privacy, so that we get to a point where it's a given that every developer, just like they care about security, good developers have good housekeeping skills around security. They have the same behavior around privacy. Those tools don't exist, so Fiss is going to solve that by ensuring that developers can apply a baseline of privacy to everything they build as a starting point. From there, that allows us to start to obviate or make redundant some of the very painful things that happen in privacy today, right? So I mentioned data subject requests. Fiss Ops already does this, right? Like it essentially automates those tasks. You can tell it what you want to do, and it will enforce that every time you get a data subject request. So it's a very powerful sort of orchestration engine. The next things that we're building are things that continue to help lower the bar for the use of Fiss. So I mentioned plugins for text or code editors, so things like IntelliJ or VS Code, so that developers don't have to necessarily write Fiss by hand, but they get assisted hinting in their text editors while they're writing it, which is going to help them ease the use of the tools. From there, we don't want to compete with security products. That's not our world at all. Our goal is to augment the capabilities of the existing pipeline. So integrations with existing static code analysis tools. So think of the ability to load a policy into your existing Sonar Cubes or SemGreps or whatever static code analysis tools you might be using, like Sneak, and have it check for things that aren't just security related, but are also privacy related. So every time developers are checking in code, it's testing security constraints, but also privacy constraints. And then on the runtime environment, so the deployed production environment, the sort of biggest unsolved problem we believe is ultimately in ensuring that a user's rights are fine-grained, so on individual pieces of information, and enforced on that data. So what I mean by that is, if I'd say, I don't want you to use my data for behavioral analysis, that's a needle in a haystack to withhold from a business system today. It's a very complicated access control. It's not really how ACL works. And I know you and I and Leah Kistner talked about this previously. Semantic access control is sort of the zenith of what needs to be achieved, but down to individual pieces of data, right? Any person listening to this should be able to say to a system, it's over the top, but I don't want you to use this one piece of data for this one purpose. And I need to know that you can respect that for me consistently across all of the systems, despite how much you scale. And that's a very difficult problem today to solve. And that's ultimately where we want to get to.
Right. There's quite a bit of defining and building it when it comes to the language that we need to do in order to achieve that level of control. But it certainly is an altruistic goal, and it's something that I share with you, obviously, as a long-term privacy advocate and professional. We've had so many great questions and great comments. Thank you for answering everyone's questions, Cillian. Are there things that you'd like to share with the TROPT community, the viewers, that, before we wrap up? I feel like we could keep talking, but this has been, I want to be mindful of your time. Obviously we want to lower the bar of entry for developers to design and engineers privacy when they're building their technologies. I'd love for you to share any calls to actions or any resources you think might be helpful for the audience.
Thank you. Yeah, thank you, Lourdes, and thank you for having me. Well, the first thing I should say, and I do mean this because we worked on it with the TROPT team. If you haven't, please review the white paper on defining privacy tech landscape. It is the best piece of research that's here this year in describing the distinction of what tools solve what problems for the industry, because there's a lot of confusion about that. So I would urge you to look at it if you have time. I really wouldn't. There's been a tremendous amount of work in it. That's one call to action. On my side, I think it's easy to forget, Ethyca is a venture-backed technology company. Yes, we are a for-profit business, so we build engineering tools to make it easier to use Fiss. But I can't impress this enough. We as a business believe that we can only make technology better for every human being on the earth if it's easy to implement for developers. So Fiss must be free. It is open source. Its tools and support documentation are all freely available. And so the biggest call to action I have is to ask anybody here to grab a copy of them, test them, break them, play with them, give us feedback, make suggestions on how you'd like to improve them. Myself and our entire engineering and product teams would love to get that feedback and improve those tools over the next couple of years, because the ambition is that we do this for the next 5 to 10 years to make things better.
Thank you for that, Cillian. And we have a couple of questions about where we could find not just the white paper, but obviously the Fiss repository, and we'll make sure to share the links to I think it's GitHub and Medium, and obviously the download for the white paper defining the privacy tech industry. Cillian, thank you so much. It's been such a pleasure, as always, to chat with you and learn more about the Fiss suite of tools. I can't wait for part 2 at some point in the future, and to learn more about what you guys have built in the roadmap, and maybe update folks who were listening today. And so with that, thank you everyone for tuning in to the Rise of Privacy Tech's webcast episode today with Cillian Kieran on building open source developer privacy tech tools. Thanks everyone. Bye.